So Phoenix is a software product. Its main purpose is to make sure that when analysts or people who need to run very large computing simulations, when they run on big clusters, that their simulations are productive, that they don't spend a lot of time or waste a lot of resources to finish their computations. And the reason we are having to do that is because large HPC systems are prone to frequent failure. And when that happens, simulations usually have to stop and then they have to restart once the system is back online. What we've done with Phoenix is to design a library that handles failures much more gracefully, much more swiftly, and enables any large calculation to progress swiftly without spending a lot of overhead.
The whole setup for Phoenix is, number one, the process recovery saves you all of the time spent on just relaunching processes every time there's a failure, which becomes a big deal when we're talking about massive scales. Two, the data recovery system gives you, maybe 8 times, maybe even greater on some of these really big systems, the checkpoint performance. So you save a ton of overhead there. And because you're able to checkpoint more cheaply, the optimal checkpoint interval actually becomes a lot shorter. So you're able to checkpoint more frequently, which means you're going to experience fewer faults per checkpoint interval. It's going to be less overhead of recomputation. And then finally, we have the message logging approach and our pseudo-local recovery model that we've designed and analytically modeled. And with that, you get these, potentially massive improvements in the total overhead of your systems.
What Phoenix is allowing is applications to only respond locally. So only the node that has faced a failure and only those nodes that are immediately affected by a failure have to roll back, which lets all of the other nodes to continue making progress by leveraging this asynchrony. The fact that they don't have to communicate every instant, that allows these other nodes to not respond or have to respond to the failure. So it's as though they are somewhat agnostic, and that asynchrony allows an overall improvement in the final time to solution.
When you start looking at the failure rates that we predict for current systems going up to the sizes that are being planned, then you see things that are, 8, 10, even up to like 18 times overhead, versus with our pseudo-local recovery model, the very highest we see is a 92% overhead. And we typically see lower than that. So it's a huge improvement. Phoenix is really the way that these future clusters can actually be used to run the scientific computing applications that we all honestly have been depending on for a long time for a lot of our progress in science and for a lot of, Sandia's mission and the missions of the United States in general.